I think this is visible to you. Same material with the permissible stresses 55 megapascal in tension, 70 megapascal in compression, and 40 megapascal in shear. 4040. So here force acting is 30 kilonewton, that is 30 into 10 raised to 3 Newton. Uh, Tensile stress sigma T is 55 megapascal, that is equal to 55 Newton per mm square. Compression stress, that is sigma C is 70 megapascal, that is 70 Newton per mm square. Shear stress tau is 40 megapascal, it is 40 Newton per mm square. You solve this considering all the 10 dimensions as we discussed the 10 points in the previous problem. The same 10 you have to consider. You can note down the 10 steps. Diameter of rod D, small d. For that you consider the tensile stress acting on the rod. So it will be sigma T equal to P divided by pi by 4 d square. Here you will get d because sigma T is known, force P is known, so you can calculate d2 here. Second one, the diameter of the spigot, small d1. Diameter of the spigot, that is the small d1. So here you know this small d1. I hope you remember this diagram. Small d1 is this one. This the inner diameter of socket or the outer diameter of spigot. This d1. For the small d1, again we calculate the thickness of the cotter T because this T is required for the d1. So T equal to 0.3 times d. This is the standard equation you can use. 0.3 times small d, so you can calculate thickness. Then to determine or to find out the diameter of the spigot, small d1, consider this tensile stress acting on the spigot, P upon pi by 4 d1 square minus d1 into T. So this is the cross section where the tensile stress is acting. So considering this, you can find out the small d1, that is diameter of spigot. Next, for the same or this, again we have to consider the crushing stress acting on the spigot, crushing stress induced in the spigot. For this you consider the force P and the area of the cotter slot, that is a d1 into T, d1 into T here, this area, so that we will consider. For the crushing, you check this, here again you will get the d1 value. So the d1 calculated for the tensile stress here, this d1 and this d1. We consider the maximum value of d1. For the crushing stress, it is maximum, so we'll consider this 72 mm as per my calculation. So maximum value you have to consider. The same dimension we are checking for the failure under the tensile stress, and here the failure under the crushing stress. Considering the tensile stress, the dimension is d1. Dimension d1 is 47, and considering the crushing stress sigma c, the dimension d1 is 72. So we'll consider the maximum dimension, that is 72. Third dimension, the outside diameter of the socket, that is capital D1. Outside diameter of the socket, capital D1. For this, we will consider the tensile stress sigma T acting on the socket. For this, P upon pi into d1 square minus small d1 square minus d1 capital D1 minus d1 into T. So this area on which this is acting for the socket diameter d1. C. Now this cross section, I hope you remember this. Now this cross section you have to consider. Here is the slot with the thickness T. Now this slot we have to omit. So the dimension of this slot or the area of this slot is capital D1 minus small d1 into T. So this you have to subtract from this ring. So that is subtracted here. So the formula is P upon pi by 4 into d1 square, that is capital D1 square minus small d1 square, minus capital D1 minus small d1 into T. So considering this, here we have to find out the dimension capital D1, that is the outside diameter of the socket. So to can find out this, you have to use the quadratic equation, then you solve this. Next is distance from the end of the slot, the end of the spigot, that is the distance A. Distance A. For this distance A, we consider the direct shear stress induced in the slot. So the tau equal to P upon 2 times D1 into A. So if you put the value of tau, P and D1, you will get the value of A here. The next dimension, fifth one, diameter of the socket collar, capital D2. This capital D2, for this we'll consider the crushing stress acting on the slot of the collar socket. The crushing stress, that is sigma C, equal to P upon capital D2 minus small d1. Capital D2 minus small d1. So capital D2 minus small d1 into T. If you consider this, put the value of sigma C, P, small d1 and T, you will get D2, that is 43. Next one is the thickness of the socket collar C. For this thickness of the socket collar C. For this we will consider the direct crushing, direct shear, that is shear stress tau equal to P by 2 into capital D2 minus D1 into C. Here we will get the value of C because P is known, D2 is known, D1 is known, so tau is known. So we can find out the C from this equation. Equation number 6. 7. Diameter of this spigot. Diameter of this spigot collar D2, small d2. For this, consider the crushing stress induced in this spigot collar. Sigma C equal to P upon pi by 4 d2 square minus d1 square. Small d2 square minus small d1 square. Here the value of sigma C is known, P is known, d2 square we have to determine, d1 square is known. So you'll get the d2 here. Now this thickness of this spigot collar T1. For this we'll consider the shear stress induced in this spigot collar, and here tau equal to P upon pi into d1 into T1. The width of the cotter B, again cotter under shear, tau equal to P upon 2 times B into T. Double shear is there, so 2 is there. 2 times B into T, you will get B here at the 32. So this is the ninth dimension, and the last one, that is bending. Quarter under bending, that you have to consider as we discussed today. The bending, you have to consider the distance of capital D1 and small d1, that distance, and force P. Considering that, you have to find out the maximum bending moment M, and then considering the section modulus, we can find out the maximum bending stress, and using that you can find out the maximum dimension of the quarter width B. So that is the 10th one. I hope you got this.